Okay guys, today we are going to do something called adding linear expressions. So we actually do have vocab today, so green on the left, notes on the right. Go ahead and take your binders out. Green on the left, notes on the right. Okay, now I do know it's called adding linear expressions. We are doing some subtraction today as well. All right. However, I'll show you what it means by adding linear expressions. Now we know what adding is. We know what expressions are by now. But the word linear is maybe where we get caught up. That adjective right there. So what we're going to do is we're going to go ahead and just talk about exactly what does it mean to have a linear expression. So that is our one word. So that word is linear expression, everyone. Okay. So here's what your book says a linear expression is. It's an algebraic expression in which the variable is raised to the first power. Okay? So just to clarify, when it says a variable raised to the first power, if we write something like 2n, that variable, even though it doesn't have an exponent, that is considered raised to the first power. Because actually, if you put a 1 right there, it would mean the same thing. We just never write that one. Okay? So that's what that's talking about. So here is some examples. So in your box here, 5x. All right, 5x. So the x is to the first power, right? 5 times x. Another one is 3x plus 2 would be a linear expression. Now here's some other linear expression, or I'm sorry, expressions that are not linear expressions. Okay, one would be something like 5mn. Okay, and you say, well, Mr. Wilkins, they're both to the first power. Yes, but actually what your book doesn't tell you is that x are the variables. You can't have more than one multiplied together. Okay, so 5mn is actually not a linear expression. Neither is, and this is a little easier to notice, 3x cubed plus 2. Obviously, right? Because it has a exponent of a 3. Okay, now let's just get down to, you still may say, okay, well, I see the examples, I see the definition, but Mr. Wilkins, I still don't know why is it called a linear expression. Well, as you get older, and maybe even we'll do it a little bit this year, is we are going to take expressions like this and we are going to graph them. And you might be knowing where I'm going with this, but the word linear is the adjective form, of course, of line. Bottom line is, this is what this is. If I was to graph a linear expression, one of these two expressions here, it is going to create a line. So as you get older, also you'll be talking, maybe we'll do it this year, we'll be talking about linear equations, linear functions. Okay, so basically what we're doing is we're just getting you ready for that next level. All right, so linear expressions. So what I'd like you guys to do is to go ahead, grab your book, and flip over to page 307. Grab a piece of paper if you haven't already done it. Put your name, date, period up at the top. All right. Put your assignment number with the assignment on the top there. Okay. On page 307, the directions say, for problem number 4, say add, use models if needed. We're not going to necessarily use a model right now, so what we're going to do is we're going to take a look at problem number 4. We'll kind of move it up here. And what we have is we have negative 7x plus 2 plus, and then the next expression is x plus 4. Now, what I just want to point out is you're going to find we'll do adding and subtracting in these problems, but what I want to point out, it's called adding linear expressions because here are two different linear expressions, and of course, we're adding the two of them. Okay. Now, what I want to point out really quickly, and this will be important in a future lesson as well, is when I go to solve these, okay, when I go to solve these, you can think of it this way. We can actually squeeze a 1 here as well as here in front of the parentheses. Now, if I squeeze a 1 in here, here's what I want to point out, okay? On both of these, if I squeeze a 1 here, I can go ahead and I can do distributive property if I would like to clear out the parentheses. Okay, remember a simplified expression doesn't have parentheses and it doesn't have like terms. I can go ahead and clear it out by doing distributive property. So here's the issue though. 1 times x, a positive x, is still a positive x. 1 times this positive 4 over here is still a positive 4. I could even do it up here. 1 times a negative 7x is still negative 7x, right? 1 times 2 is still positive 2. You get the idea. So, here's what I'm getting at. Because this is an addition sign here, we can squeeze a 1 in, and you could waste your time doing distributive property, but we're going to just cut that part out of this problem. Because it's an addition problem, here's what we're going to do. Step 1, because we're going to get the same thing because of the addition sign, we don't have to go through all that. We can just drop the parentheses and rewrite the expression. You'd end up with the same exact expression. So if I drop the parentheses, I end up with negative 7x plus 2. And if I want to, I could put the addition sign, of course, with the x plus 4. Okay, now here's what I'm going to do, is I'm going to go ahead and do step 2, probably have a good idea, is I'm going to go ahead and combine like terms. Okay, so we're just taking and using some basic steps of yesterday's lesson. So if I take a look here, here's a negative 7x, an x term, so I'm going to box it in with my negative. I look for other x's, x term here. I box it in. Now just keep in mind, this is very important. This is a plus x or a plus 1x. Okay. Now, also, I have a constant here, a positive 2. I have a constant here, a positive 4. So when I combine these, negative 7 plus 1, I really recommend, at least for right now, many of us need to put a 1 in there because we may just ignore it and think it's 0. But this is a negative 7 plus 1, which gives us a negative 6x. And then we have a positive 2 plus 4, which gives us a positive 6. Once I get here, I look and I say, okay, well, no parentheses, no like terms. That is our simplified expression, adding linear expressions. Okay, so that's pretty much everything to it. You might want to make yourself a little note, and this is very important again. Step 1, right, is just to drop parentheses and rewrite it. And that can only be done because of that addition sign right there, because they're both positive expressions in front of the parentheses. Okay, so here we go. What I'd like you guys to try out is problem number 8 on page 307. Go. Okay, so what I'm going to have you guys do now is go ahead and turn to your neighbor. What I'd really like to see you guys do is share your answer, but I want you to double check with your neighbor. Make sure that when they ID'd their terms, that they're still including those signs in front or to the left of the number or of the coefficient. Okay, so go ahead. I'll give you 30 seconds. Turn and share. Go. Okay, here we go. So what I have is I have two expressions. They're being added together. Because of that addition sign, I can rewrite it by dropping the parentheses, negative 7x plus 1. If you put a double sign, that's okay, but you might want to, instead of saying plus negative x, just write minus x plus 2. So when I combine like terms, here we go. Negative 7x, I look for other x terms. I have a negative x here. Right here is a positive 1. I'm going to circle it. And a positive 2. I'm going to circle it. Now, when I take a look here, I'm going to go ahead and combine my x terms. Don't forget, this is negative 7 minus 1. Negative 7 minus 1 gives us a negative 8x. And then 1, positive 1 plus 2 is a positive 3. Negative 8x plus 3. All right. Now we're going to do one more together, and it's pretty much the same thing. It's just a word problem. It's not much more difficult. All right, just have to make sense of it. Let's go ahead and take a look at problem number 5. Problem number 5. So number 5, of course, is use the figure at the right. Okay, you have a quadrilateral over there, and it says write and simplify a linear expression for the perimeter of the figure. All right, so ladies and gentlemen, this here, if we had something that looked like that, okay, I guess I could have done a better job at drawing a quadrilateral, but if this was 2 units in length, this is 3, this is 4, this is 5, and I said find the perimeter, a majority of you, of course, would just add up all the numbers. And that is exactly what we're doing here. Now, obviously, there's not a bunch of numbers. These are expressions, okay? So I'm going to go ahead and write it down. So this side isn't 3 on your book, it's x. This side here isn't 4, it's 2x. So here's what I'm going to do. X plus, I'm going to put in parentheses 2x. Plus this side here isn't 5, it is 2x minus 2. Plus this side up here is 2, right? Well, in your book, it's x plus 5. So if you're going to put steps on this, you would go ahead and put just step 1 is write your long expression out with all the smaller expressions. Bottom line is all the sides are being added together to get the perimeter. Okay? Don't forget, of course, and if you want to, you can put parentheses around the x as well. You don't have to. Okay? So now, bottom line is step 2 is, I'll just say, simplify. Because at this point, simplifying is what the 2 steps were up here. Okay, all addition, because it's all addition, I can just go ahead and drop parentheses. So I have x plus 2x plus 2x minus 2 plus x, or 1x, for those of you that want to put the 1 in there, plus 5. Combine like terms as part of the simplifying. So I'm going to go ahead and box in all my x terms. There's x, there's a positive 2x, another positive 2x, and a positive 1x, or an addition of 1x. These 2 are constants. They're both the same. I'm going to go ahead and circle them. So when I combine, I have, remember, 1 here. So 1 plus 2 is 3, plus 2 is 5, plus 1 is 6. We have 6x. And here I have a negative 2 plus 5 is positive 3. And there are no specific units. Okay, so you could put down just the generic word units. And that is the answer to what they have is 5A. Okay, now 5B, let's spend a couple seconds on this. 5B says find the perimeter of the figure if x is equal to 4. Now here's the neat thing. You don't have to go back here and plug 4 into all this and recalculate. We have a simplified expression. Here's all we have to do. They're defining the variable. All we need to do is use parentheses, plug 4 in for the x. And when you do that, follow order of operations, we have 24 plus 3, which of course gives us 27 units. Okay, so I'm going to give you one very similar like that to try. All right, here we go. Number 12 on page 307. Number 12. All right, go. If any of you are done early, make sure you work ahead on your homework while you're waiting. Okay. Okay, 30 seconds. Go ahead and turn to your neighbor. Share both of your answers. All right. If you don't know what I'm talking about, right? They didn't give you an A and a B, but they did have everything set in direction. So make sure you share both of your answers. Turn to your neighbor and share. 30 seconds. Go. Okay, here we go. All right, so page 307, problem number 12. All right, the directions say for each of the figures, write and simplify a linear expression for the perimeter of the figure. So very much like our last problem. Then it goes on to say, then find the perimeter of each figure if x is equal to 8/10. So it actually defines a variable within the direction. So here we go. Perimeter, right? All three sides, they actually have units on these, right? It's all three sides added up. So here we go. We have 9x minus 4 plus 9x minus 4 plus 2x plus 3. Okay? They don't have to write centimeters within the problem. Again, all addition, right? So because they're all addition, it's not, the value's not changing inside the parentheses. Okay, so we can drop the parentheses and rewrite it without. So 9x minus 4 plus 9x minus 4 plus 2x plus 3. Okay, simplifying the expression. 9x, I'm going to box in all my x terms. 9x is there, positive 9x here, and a positive 2x here. This right here is a constant. I'm going to go ahead and circle it. That's a constant. I'm going to circle it, and there's a constant. I'll circle it. So I go ahead and simplify this by combining all my like terms. 9x plus 9x is 18x. 18x plus 2x is 20x. Constants, negative 4 minus 4 is negative 8. Negative 8 plus 3 is a negative 5. So we have 20x minus 5, you can say units. That's the first answer. Now for the second answer, we need to plug in, of course, 8/10 for x. 8/10. We do the multiplication first. So I bet you a lot of you guys can do that in your head, but if you can't, 20 times 8/10 equals, and that gives us 16. Bring down my subtraction of 5. Okay, and 16 minus 5 equals, of course, 11. In this case, 11. And you know what? It gave us specific units, right? It's centimeters, which means this isn't units, this is centimeters. And there is our generic simplified expression. And here is if the x equaled 8/10, it'd be, the whole perimeter would be 11 centimeters. All right, and that is adding linear expressions.